is this. What we want to do is we want to sketch this graph. Now I'm not going to bother too much with the details. I just want a little sketch. But I just want to look at this for a second. I have to learn how to read what this says. What this says is, when is this quadratic less than 0? That's what it says. When is the quadratic less than 0? So I recognize that this is a quadratic. I know how to graph quadratics. So what I'm going to do is I'm just going to take a minute to graph this quadratic. There are lots of ways that you know how to graph a quadratic. Okay? I'm going to pretend it's 0 for a minute. I know there are lots of ways you know how to graph a quadratic. You can use the axis of symmetry and find the vertex. You could use the y-intercept. You could make a table of values. There are a lot of ways you could graph the quadratic. What I'm most interested in is the x-intercepts, though. So I want to find the x-intercepts of this. So for the past 3 weeks, we learned 5 different ways of finding x-intercepts. Quadratic formula, complete the square, factoring. Sometimes there was GCF factoring. Sometimes I could use my square root property. Okay? Which method do you think would work the fastest on this problem? Factoring is definitely, this one is very easy to factor. If I can factor it, I should factor it because factoring is so much faster than the quadratic formula. How would this one factor? I got x and x. How do you get negative 10? That adds up to give you negative 3. Negative 5 times positive 2, right? This will be on your test on Thursday. Well, this type of problem all by itself. So now I would take my x minus 5, that equals 0, and my x plus the 2 equals 0. I know some of you can skip this step and automatically go down to my 2 roots, 5 and negative 2. Now I just used the word roots. These are roots, right? Or solutions. Or x-intercepts. They all mean the same thing, don't they? Okay. Oops. So, sketch a graph. I just need a sketch. I don't need it to be pretty. I just need a sketch. Here is one root at 5. Here is one root at negative 2. I know that I have a parabola, a quadratic, that will cross the x-axis here at negative 2 and here at 5. Does this quadratic open up or down? Yeah. I have to disagree. I think it opens up. Isn't A positive? Yeah. Positive 1. So I know that it's going to face up. I'm looking at this sign and we just talked about this. Is this going to be a solid or dotted line? Dotted. So I'm going to do a dotted quadratic that faces up. Now, if I wanted to, you could tell me this point right here, the y-intercept, it's negative 10, isn't it? I don't need it, but if I wanted it, I could have it. If I needed to, you could tell me the vertex. You could go find it, right? Use your formula, or change this whole thing to vertex form. Okay, you can do any way you want to, but all I need are these points. So let's talk about it. Remember what my original question is asking me. When is this quadratic, which is this dotted line, when is this dotted line less than 0? All right? Right here is 0. That's 0. When is my quadratic less than that? Here. That's when it's less than it. Okay? This part up here, I don't care about. This is the part that's less than it. So describe to me when this happens. It happens here to here, right? So my x's are between what two numbers? Negative 2 and positive 5. And do you remember doing set notation back at the beginning of the year? Okay. When is this quadratic bigger than 0? The easiest way to graph this problem would be factoring. I'm not trying to make this hard, guys. It would be factoring. How would this factor?
Seven and negative 5.
Yes, you're welcome. 7 and negative 5. All right. So we're just going to find the roots real quick. Can I skip this step? All right. X is going to be negative 7. X is going to be positive 5. So I know right now my roots are negative 7, positive 5. You notice I'm not trying to make a super detailed graph. Will this graph be a solid or a dotted line? Right here, that's going to be solid, isn't it? So I'm going to do a solid line. Is it going to face up or down? Up. A equals 1, so that faces up, right? So I've got a solid line that looks something like this. If you wanted to know this point, could you tell me? What is it? It's negative 35. It's right there in the equation, right? If you wanted to know the vertex, could you tell me? All right, you could. You'd have to figure it out, but you could tell me. Okay, but I don't even need that information. I want to know, when is this quadratic bigger than 0? Where does that happen? When is this quadratic bigger than 0? Well, it's actually not between them this time. This time it's here and here, right? It happens whenever I am less than negative 7. Negative 7, negative 8, negative 9, negative 10. All of those would give me something up here in the yellow, right? So everything that is less than negative 7, actually, should I say less than or equal to? Or it could be anything greater up here, greater than 5. 5 gives it to me, 6, 7, 8, all of those. So anything greater than 5, greater than or equal to 5. So if I write that in set notation, looks like this. The word or is in there somewhere. Okay, there's two fundamental ways of doing this, and your instincts tell you to subtract 14, and I'd agree with you. That's what most people would do, I think. So if we subtract 14, we're going to get x squared minus 5x minus 14 is greater than or 0. And then I'm going to do it just like I did it, right? So all this is going to work out. Does this happen to factor?
Negative 7.
All right, it'd be nice if it did, and it does. So x, negative 7, positive 2, skip down to the answer. X equals positive 7, x equals negative 2. So there's my negative 2, sorry, negative 2. I don't like that. Let's try this. There's my negative 2. Here's my 7. Is it solid or dotted? It's dotted, and it faces up or down? Up. So I've got a dotted line that faces up. Looks something like this, right? And where's the solution? Okay. I want to be, oops, wrong part. I want to be bigger than 0. Bigger than 0. Where is it bigger than 0? Here. Oops, that should have been dotted, right? That's bigger than 0, and that's bigger than 0, right? So less than negative 2, x is less than negative 2, and x is greater than 7. Okay? But I said there's two fundamental ways of thinking about this. That's just one way. Okay? We actually solved a different problem, didn't we? We took a problem, x squared minus 5x is greater than 14, and we changed it to something that looked more familiar to us. Okay? But the real problem said x squared minus 5x is greater than 14. Well, why not do that one? Okay? I want to fundamentally think about what this is trying to tell me. This is trying to tell me when is x squared minus 5x bigger than 14. X squared minus 5x is a quadratic graph. Do you recognize it? Forget about the whole thing. Just think about this. That's a quadratic graph all by itself, isn't it? Okay? It's a U-shaped graph. I could totally graph this. Okay? Over here, that's a linear graph. I actually am asking, the real question that's being asked is, when is this quadratic graph bigger than this linear graph? Well, do you know how to graph a quadratic? Do you know how to graph a line? Well, then let's graph a quadratic and let's graph a line. Let's cheat. Let's use the calculator. All right. So on our calculator, we can see that here's my quadratic and here's my line. This was the line, y equals 14. This was the quadratic. Oh, I barely have room for it. X squared minus 5x. I know that was a 0. I know that's a 5, but those don't really matter. What matters to me is this point and this point, right? And that happens right here at -2 and right here at 7. And just like on the last one, it's bigger above it. Actually, those should be dotted lines, shouldn't they? But so it's a dotted line, but it's above it. So my answer is just like the last one. My answer is x has to be less than -2 or x is greater than 7. So just real quick, we're going to use our calculator to graph this, but it says the height of the ball above the ground is thrown upwards at 40 feet per second and can be modeled by this function. Remember where I told you that 40 feet per second comes? See the 40? 40. I told you -16 represents gravity. All right, pulling it back down. Where x is the height of the ball and time is in seconds. At what time in its flight is the ball within 15 feet of the ground? So in other words, the ball has to be what? Less than or equal to 15, right? That would be within 15 feet of the ground. Okay. Well, I've got the function already. So I'm looking at, there's two ways of doing it. This would be my 15 feet, wouldn't it? Y equals 15. Can I graph this? All right, well, let's use our calculator and graph it. We know that this does this. Okay? This function is this U shape. We know this happens right here. We found the intersection of that, and we said it was 0.42 seconds, right? We found the other intersection here, and it was 2.04 seconds, right? And then when does it hit the ground? All right. So any way you choose to solve it is fine, but that would tell you that that point right there is 2.5. So talk to me about when is the ball less than 15 feet? Anytime greater than 0. Oops. It has to be greater than 0, right? Because I have to hit the ball. But then it has to be less than or equal to 0.42. That represents this part right here, right? Open circle here, closed circle here. Now what about that other part? What about over here? It has to be bigger than 2.61, right? But it hits the ground at when? Was it 6.1? It couldn't have been 2.01, sorry. 2.04. Okay, sloppy handwriting. 2.04 and less than 2.5, right? So that's where we're looking.